Hey guys, can I show you something very interesting in mathematics? Well, check this out. So would you say that this statement is true? 1 is equal to 1. And intuitively, you're like, well, yeah, of course, 1 is equal to 1. Now, would you say this statement is true? 1 is equal to 0.99, repeating. That means that this 9 goes on forever into infinity. You might say, well, not really. I mean, they're close to each other, but they're not exactly the same. Let me show you that that's actually not true, that these numbers are actually exactly the same. Not infinitesimally close, but exactly one is equal to the other. Now, how would we prove that? Well, we can prove that 1 is equal to 1 by saying 1 minus 1 is equal to 0. And that proves that they're equal to each other because if you subtract one from the other, they cancel each other out and you're left with nothing. Well, let's try that now with this statement. So we'll start off with 1 minus 0.99 goes on forever, and we're left with 0.00, and then that goes on forever. When I first saw this, I'm like, well, sure, but you know, there's a 1 eventually, so no, they're still not equal to each other. It's a cute trick, but that's all it is. It's a trick. But you have to understand, though, that infinity is not a number, it's a concept. So you actually never get to that one because it goes on forever. You're like, okay, yeah, sure, fine, I agree with you, but in your mind you know that the one's over there. But let me show you another way. So we'll start off with a statement that says s is equal to 0.99 goes on forever. And we're trying to prove that 1 is equal to 0.99 goes on forever. So that's what we're trying to prove. So we'll begin with this statement. And now we're going to go ahead and grab this statement and we're going to multiply it through by 10. So we're going to say 10 times s is 10s equal to, we'll go ahead and multiply 10 times 0.99, so we get 9.99 goes on forever. And all we did was just move the decimal point over one space, and so we get 9.999. And so let's subtract these two from each other, and we get 10s minus s, that's 9s, 9.99 repeating minus 0.99 repeating. Well, we can say that after the decimal point, these are actually equal to each other, so these cancel each other out. So 9 minus nothing is equal to 9, and we're left with s. Well, we'll go ahead and divide by 9 on both sides, and we're left, this cancels out, and we're left with s equal to 1. And so if we plug s back in here, we see that it says that 1 is equal to 0.99 repeating. So that's showing to you algebraically. And now this has been proven not only algebraically, but using calculus and using all sorts of different mathematics, that this is a true statement. And just as a final proof, let me show you just one more way, and I think this, you'll be convinced after this statement that, okay, fine, it is true. So now would you say that this is a true statement? We're going to begin with 1/3 is equal to 0.33 repeating. Let's go ahead and we have a calculator here. Let's do it on our calculator. 1 divided by 3, and it's repeating. Now it obviously stops on here because you only have so many digits, but we have the advantage here of increasing the number of digits. We're only limited to how many 3's we can see by our screen size, but this goes on forever. So that's a true statement. So let's go ahead and multiply both sides by 3. So we're going to cancel these 3's out on this side. We're left with 1. And we're going to multiply this 3 by this 0.33, and that is equal to 0.99 repeating. And so there you have it. 1 is equal to 0.99. So what's been really interesting for me looking at this is to really get to know what that infinity actually means. And numbers are just a construct. It's a way to represent our physical world and a way to make sense of it. And I noticed that as we begin to get close to the edges of our constructs, that things kind of begin to break down. And we see it here as we get to infinity, things aren't so intuitive anymore. Now, what the most interesting thing has been, though, is people's reactions to it. And I've had friends who have become very agitated and pretty upset about it, and it's been fun to go back and forth on it and over a period of days. And so I recommend for you to show it to your friends, and I guarantee that you're going to get some interesting reactions, even for people who really aren't interested into math. It's cool.